For example 5, it asks us to determine the vertical asymptotes of y is equal to 2x over x squared minus 3x plus 2 and sketch the graph near the asymptotes. So we're going to start by saying if y is equal to 2x all over x squared minus 3x plus 2, then we're going to factor down that denominator and say that's going to be 2x all over x minus 1 and x minus 2. We know from that our domain is going to be x cannot equal 1 or 2. And because there's no common factor in the numerator and denominator, I also know that there's going to be vertical asymptotes at x is equal to 1 and x is equal to 2. So let's take that first vertical asymptote. If I take the limit as x approaches 1 from the left for 2x all over x minus 1 and x minus 2. We know that we can't actually put in the actual value of 1 in there because it's just going to say undefined. So if we're approaching 1 from the left, we're going to get as close as we can to 1. So say something like 0.9999999, however you want to put it in. And what happens is, if we have 2 times 0.999999, we get a positive value. If we have 0.999999 minus 2, we get a negative value. And if we put in 0.999999999 minus 1, then we're going to get a negative, very small number. When I'm approaching a very small number and I'm dividing out a very small number, then that is going to approach infinity. And because the negative and the negative cancel out here, I'm going to be approaching positive infinity in this case. If I do the same thing where I take the limit as x approaches 1 from the right-hand side for 2x over x minus 1 and x minus 2, then that's going to give me a positive. It's going to give me a positive very small number. And this is still going to give me a negative. So it's still going to approach infinity, but because I have positive, positive, and negative, it's going to approach negative infinity. If I take the limit as x approaches 2 from the right, then I'm going to get 2x over x minus 1 and x minus 2 is going to become, if it's 2 from the right, well here actually let's do 2 from the left first, just to make it consistent. Doesn't make a big difference, but I just want to keep it consistent. 2 from the left, then I'm going to pick something like 1.99999, and I'm going to get a positive value. I'm going to get a positive value, and I'm going to get a negative, very small number. And we can see that this is also going to approach infinity, and because I have a positive, positive, and negative, it's going to approach negative infinity. And last but not least, let's use this one. If I take the limit as x approaches 2 from the right-hand side for 2x over x minus 1, x minus 2, then that's going to give me a positive, and a positive very small number, which is going to give me positive infinity. I'm going to do a little sketch of what we've just learned. So we're pulling from our vertical asymptotes at x is equal to 1 and at x is equal to 2. When we approached 1 from the left, it shot up to positive infinity. When we approached 1 from the right, it went down to negative infinity. When we approached 2 from the left, it went down to negative infinity. And when we approached 2 from the right, it went up to positive infinity. For example 6, it says determine the vertical asymptotes of y is equal to x plus 2 over x squared minus 4 and sketch the graph near the asymptotes. So if y is equal to x plus 2 over x squared minus 4, then just like in the last case, the first thing we're going to do is we're going to factor the denominator, and we're going to say that x plus 2 over x plus 2, x minus 2 is going to be where we get our y from. Now we can see that we can cancel out an x plus 2 from the top and the bottom, which we know is going to create a point of discontinuity at x is equal to negative 2. So it's not actually going to be one of our asymptotes. Now, it will still count towards our domain from our factored form. X squared minus 4 cannot equal 0. My denominator cannot equal 0, which means that x squared cannot equal 4, and x cannot equal positive or negative 2, which we could also solve from the factored form of our denominator here. This leaves us with y is equal to 1 over x minus 2, where x cannot equal positive or negative 2. And based on our simplified form, we know that we have a vertical asymptote at x is equal to 2. So we're going to solve the limit as x approaches 2 from the left for 1 over x minus 2. And we're going to solve the limit as x approaches 2 from the right for 1 over x minus 2. When I'm approaching from the left, I'm going to pick something like 1.99999, which is going to give me 1 over a negative, very small number, which is going to approach negative infinity. When I do from the right, I'm going to take 2.0000001, which is going to give me 1 over a positive, very small number, which is going to approach positive infinity. We draw our vertical asymptote at x is equal to 2, and we know that when we're approaching from the left, it's going to approach negative infinity, and when we're approaching from the right, it's going to approach positive infinity. And yes, if we keep sketching it out, we would need to include that point of discontinuity that is going to exist in here. All right, let's take a look at one last example. So for example 7, the vertical asymptotes of y is equal to x minus a over x squared plus bx plus c are shown in the following graph. So I can see that I have a vertical asymptote here at x is equal to negative 3. I can see that I have a vertical asymptote here at x is equal to 4. Now I know if I have a vertical asymptote at x is equal to 3, then I should have a factor of x plus 3 in the denominator. If I have x is equal to 4, I should have a factor of x minus 4 in the denominator. So when it says for part A, what are the values of b and c, then we can say that if x squared plus bx plus c is equal to x plus 3 times x minus 4, then x squared plus bx plus c is equal to x squared minus x minus 12. Once again, pulling those two factors from the vertical asymptotes, because we know x squared plus bx plus c is just the denominator. Therefore, b has to equal negative 1, and c has to equal negative 12. What are the restrictions on A for all functions of this form with the same vertical asymptotes? We know that in this case, A could not equal negative 3 or 4. The reason we know this is because if A is equal to negative 3 or 4, then it would cancel out from these factors, which means that if A was equal to negative 3 or 4, it would create points of discontinuity instead of vertical asymptotes. And that's it.